Hi there, how are you all doing? IGBits welcoming you all for a happy learning. We train, you will get an opportunity to learn. So we are going to start a new topic called trigonometry introduction. I'm sure I think you are all familiarized this topic, as this is also covered in middle grade and then upper high school standards, like it 10th grade, SSC, CBSE, and ICSE, a sort of curriculum. And precisely in 10 plus 1 and 10 plus 2, so-called intermediate standard, where extensively this topic is important, and then everyone should have to learn, because most of other mathematical chapters are depending upon this topic, in a way. So the way forward, we are going to leverage trigonometric functions, formulas for solving integration, differentiation problems. So this is kind of a prerequisite. Okay, and then uh, one important thing, just I wanted to let you know that if you can start building concepts from the basics, like a basic building blocks, this chapter pretty much like easy to understand and then doable, can construct concepts and then able to solve whatever the problem is given. Okay, uh, without waiting further, let's get started and then started familiarizing what are the prerequisites that are needed to kickstart the trigonometry learning. Let's get started. One burst of word. We have a YouTube channel. I'm sure I think you are visiting. If not, visit us at the rate IGBits in YouTube, and then please feel free to subscribe the channel, and then request you all to share our channel information to your friend circle, so that everyone gets benefit out of it. Okay, thanks for all your support as such. So let's get started with like introduction part. you know uh, so what you see on screen, this is sort of line, is it? And then you can say this is like a ray, because I can see like there is an arrowhead indicated, isn't it? One is like at a terminal, other one is like moving towards this direction, some direction. For instance, this I would also rather call as a ray, or a straight line passing forward. Okay, so let me take like one more, right? This is a similar, the another ray, you know. Now what happens is like these two, if you try to join together at one end, then this is how I think it look like, isn't it? So what that means is like, if I have a ray, and then this is initial line, this is like a terminal line, and then both are get connected, make like a join together, and then this joining point, what we can call it as a vertex. That's the basic thing. So let me see. This one vertex, right? So this is a initial line, this is a terminal, just for instance. Okay, and then the angle that is making after you join these two lines is called this one, let's say theta. Okay, so how angle is going to form, you could see it here, right? So the two lines joining at one end, and then making an angle theta. I would say the terminal ray making an angle with horizontal line, you know, uh, at a theta degrees. Okay, that the theta value is depends upon like how much separation that I have between these two lines. Okay, if I have a wider space like a wider angle, smaller space is a smaller angle. Clear? So I'm repeating, an angle is formed when two straight lines or rays meet at a common endpoint. Correct, no? These are the two rays meeting at a common endpoint. A common point of contact is called as a vertex. So this one is called as a vertex. Okay, the word angle comes from the Latin word named angulus. Angulus means corner. So this corner is what we named as a angle, theta. Okay, a smaller angle for a smaller separation. The separation between these two lines, how much? If it is small, then the theta would be the small. If it is wider, then the theta would be longer, like wider. Okay, so that is how I think the basic concept of like how the angles that we learned part of your uh, triangles geometry, those concepts. So now you can see the distinguish between these two, and then the angle of the separation between these two lines is wider for the wider theta, smaller for the smaller theta. Clear? Let's move on to the next topic. We also studied about triangles, isn't it? Good. So what do you learn about triangle? So triangle means like there is a two sides form in the shape like a triangle. We have a various types of the triangles we have, but ultimately one thing for sure that we could remember ourselves is like sum of the angles of the triangle is equal to 180. If I would say these angles, right, and are this, so we can say like a total always like 180. Let me write them back, assuming this like this is A, this is B, and this is C. I can note down same A, B, and C. Okay, so angle A plus angle B plus angle C equal to 180. Okay, irrespective of the triangle. So this you can see this is a 90 degrees angle. This means like a right angle triangle. Okay, there are the other triangles that we can look at in a while, but one thing that we have to remember here is that sum of the angles of a triangle is equal to 180. Okay, this property is going to help us. And then if you look at a triangle, what we can remember also, there is a three angles and there are three sides. Okay, and then we have the properties of triangle. So one of the properties what we are saying is like a sum of the angles equal to 190. 180. So what are the different type of triangles that we learned? Okay, so see this one. This marking means I have a three different sized triangles. These are the sides of the triangle, and then length of the triangle seems like a different. Each side has its own value. Means like no side is equal. Okay, no sides are equal. So this triangle, what we name them as a scalene triangle. So when you see this statement, that means like these are unequal sided triangles. Look at this one. In this case, I have like a two sides are equal. This is what my indicator. When I have like a single line crossed on the side means that these two sides are equal. So opposite to these two sides there is an angle, right? These angles also kind of equal. So we have to whenever you seeing this property like two sides are equal or two angles are equal in a triangle, that means this is called isosceles triangle. So when you name them the triangles, then we will get the basic properties of the triangle, the sides and angles, how they're related to each other. Okay, look at this one now. This is a equilateral triangle. What does that mean? All three sides are equal. When all sides of the triangle are equal, then the angles also must be equal, right? So can you guess like what would be the angle of equilateral triangle? 180 divided by 3 is equal to 60. So each angle is 60 degrees here. Is it? So you say like 180 total sum of the triangle divided by 3 equal to 60. So that means this is 60, this would be 60, and this also would be 60, right? In this case, you see, if at all this is a right angle triangle, if this is 90, then we can say this is 45 degrees, right? Because that is how I think these lengths are equal. So let's see like two few more. These are the sides topic. Now you can see like, you know, with respect to angles, how you can name them. All angles are acute in this triangle. Means like when you see less than 90 degrees angle, then this triangle is known as a acute triangle. Okay, all angles within this triangle are less than 90. That's also a property that we can remember. Next one. Oh, cool. What do you see? One, we have greater than 90. You know how? Why it is greater than 90? Because if you take a straight line here, this is like 90, and then it is a greater than 90, right? So and hence we say that like this is called obtuse triangle. So one angle must be obtuse in this triangle. Okay, obviously you cannot have like a two angles within the triangle is greater than 90, because the sum of the angles within the triangle are max 180, right? So if the one is 90, then sum of other two would be 90, right? If the one is greater than 90, then a sum of other two angles would be less than 90, right? Obtuse triangle can be identified with this property. Okay, so let's look at now right angle triangle. So the one angle is 90 degrees, then sum of other two angles must be 90. So what each one depends. If 30, 60, 45, 45, you know, something like that is in a variant. Now you see, based on the sides, we have three types of triangles: a scalene triangle, isosceles triangle, equilateral triangle. Based on the angles, we have a acute triangle, obtuse triangle, and the right angle triangle. These are the basic triangles concept that we require, you know, when you're getting into deep dive of like trigonometry. But this is sufficient. We don't require to think beyond for now. Now let's look at a circle, right? Angles in a circle is 360. That we studied already, right? Is it? Good. So what is this line? It's a horizontal line, maybe x-axis. You can look at a vertical line, right? This is the vertical line, isn't it? So in a circle, so we all learned, but if you can recap, this is, I'm fitting this in the quadrants, quadratic geometry. This is x, positive x, this direction. This would be the negative x direction, x-axis. This is y direction. This is a positive y. This is negative y, isn't? And then this total circle is 360. We are divided into four parts, right? Each part is like an equal area, right? So this portion is like 90 degrees, and this portion would be another 90 degrees, and then this portion would be like another 90 degrees. This portion would be 90 degrees. So 90 plus 90 plus 90 plus 90, how much? Equal to 360. So that is how I think angles can be distributed here. So we can also call as this is a first quadrant, this is second quadrant, this is third quadrant, right? This is a fourth one. Okay, and then within the coordinates, right? When you represent the point in the coordinate system, we need to understand the signs, right? Any point within this area, right? Any point in this area would be like a plus comma plus. X and y points would be plus comma plus, right? Because positive x and then positive y. Look at here now, negative x and positive y. So if you want to represent something here, it is minus x and then plus y. Right? This is how you can represent any point in this area. Okay. Whereas a third quadrant, both x is minus and then y is also minus. Got it? In the fourth quadrant, you see x is positive and then y is negative. Okay, these are the few things that we have to understand. Okay, if you look at a coordinate geometry in our coordinate system, what you see, this is a plus axis, this is a plus axis, this is a negative x, this is negative y, right? So that's why this is a plus plus point can be represented here, minus plus point can be represented here, minus minus point can be represented in this quadrant, and then plus minus in this quadrant. Okay, so we say like first quadrant, second, third and fourth, right? This direction is called anti-clock. You can look at your wristwatch, then you can say this is a clockwise direction, anti-clockwise direction. Okay, another concept that we must need to learn or should know is Pythagoras theorem. Sometimes we can call it as a Pythagorean or the Pythagoras. Sounds a familiarized word, right? So for all. Okay, as per this theorem, the fundamental relationship in Euclidean geometry between three sides of a triangle is what it describes. What this theorem states that area of squares whose sides is the hypotenuse. Hypotenuse means like the side opposite to the right angle is equal to sum of the areas of squares on other two sides. This is a simple principle on which you can calculate missing side from the known other two sides basically. Let's see like what I meant to say. Right, this statement talks about hypotenuse square equal to side square plus side square. Look at this diagram. If I have a right angle triangle, okay, within the right angle triangle, if I am observing from this point, okay, in that case, which side is like opposite to mine? If I am observing from here, this is one, right? So that's why this side we can call it as an opposite side, and then this one is the base, right? The base and then opposite sides are known to us, and then the joining of opposite and then base, we have an angle. This is a 90 degrees angle. This is like a right angle, right? The side opposite to the right angle is known as a hypotenuse. So what this theorem says is like square of hypotenuse equal to opposite square plus base square, adjacent square, right? This is the theorem. But with this principle, we will be so calculating unknowns from given data in right angle triangle. This is very useful, and then I'm sure I think you all know about it. So what do you see here? Square. So properties of square, all sides must be equal, right? So if at all I have given 4 units of one side, then how do you calculate a area of square? We know the area of square formula, side into side. So 4 into 4, this is 16. I'm sure it. So you have 4 is a side, that means like all 4 sides should have same length, and then that is how I think you can call it as this is a square. And then if you can calculate the area of a square, then the formula is side into side. So multiplied by side into side. So how much? 4 times 4 equal to 16. Is it? So 16 square units is your area. Now see few more squares. I have 3 squares here of units also represented in. So this square of having 5 units a side, and then this small square having 3 units a side, and then this square has 5 units a side. Right. So if you look at the area of each one, right, how many units I have? See, I have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So 21 22 23 24 25, right? So as per the formula, square, right, 5 into 5 side into side is equal to 25. So I have a 25 unit squares within this the bigger box. Okay, now let's look at this one. I have 1 2 3 4 5 6 7 8 9. So for this small square, if the my side is 3 units, then area can get it like 3 into 3, right? This is like a 9 units. So I have a 9 unit blocks, isn't this is like a unit block. I have 9 units here. Let's look at now here 4. So what would be the area of this square? 4 times 4, right, which is 16. If you can count from here, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. So that means like the 16 unit square units what I have here unit, and hence the total area is like 16. The logic you see, this is 25, this is 9, this is 16. So 25 equal to 9 plus 16. Agree? 9 plus 16, how much this one? This is also 25. So 25 is equal to 25, and hence so this square plus this square equal to this a bigger one. This is a sort of logic that Pythagoras talks about for us. Okay, we will see that. So if you can go a little more in detail of what Pythagoras theorem states about, let's bring the right angle triangle. Okay, in this right angle triangle, we have to see, one right angle that we have. So angle B is 90 degrees, right? Angle B is 90 degrees, and then this is a observer point. This is a theta, from which you can see, the this side. This is called opposite side. This one is like a adjacent side, and then the side which is opposite to 90 degrees right angle triangle is called hypotenuse. Right? This is a right angle triangle, and Pythagoras theorem only can be applicable to the right angle triangles. Okay, so let's prove how this formula derived from this basic statement. So assume I have 3 sides are given. Opposite side is like a 3 units, and then adjacent side is AB equal to 4 units, and then hypotenuse is like 5 units. What I will do, I will try to construct a square using these lines. Okay, if I say 3 sides, 3 units is like a one of my side of a triangle, make use of this 3, I can construct a square like this, right? What would be the area here? This would be 3 into 3. How much? So 3 into 3 equal to 9 units, isn't it? So for this side I can get 9 square units square. Okay, now look at extension of other. So if you look at a 4 unit side and then construct a square with this side, then I will get like a 4 into 4, 4 times 4, 16 square units square, right? The area of the this particular square is like 16 square units. Similarly, if I can get a square extended with hypotenuse side, this is called 5 units, and hence my area of the square would be 5 into 5 equal 25 units. So what Pythagoras talks about is this square, right? This square, area of this square is a sum of the area of other two squares. That's what he talks about. Okay, so if I see, let me write this one. So this one is 25, so this area is 25, and then the small one is 9 because we said 9, this one, right? And then this is 16, so I can put 16, and hence 9 plus 16 is 25, which we have seen already. So now you see, so the Pythagoras basically talks about this. Is it right? So the basic formula is hypotenuse square equal to side square plus side square. Let's look at this now. What we can do here, constructing a small right angle triangle, and when I say right angle triangle, this must be 90 degrees. What you can give, maybe you can give sides like 6, 8, and then tell me how much this one. Okay, as per Pythagoras law, what you are talking about, like hypotenuse, right, square equal to adjacent square plus opposite square, isn't it? So means AC square equal to AB square plus BC square. So using this formula you can try to derive this one. Let's say this is H. So H equal to 6 square plus H square equal to 6 square plus 8 square, right? 6 square means 36 plus 8 square is 64. So summing of 36 plus 64 gives rise to 100. So H square equal 100. So H means square root of 100, right? Which is equal to 10 square, right? Root. So it's 10. So 10 units is your hypotenuse. So 6, 8, 10. If a triangle has these sides, so you must think that this is a right angle triangle. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Let's recap what we have seen in today's class. We have seen basic concepts like straight lines and then joining of two lines, making an angle form, and then how a separation between these two lines of a common joining point versus angle, the relationship. A lesser angle means like a lesser separation, and then wider angle means like wider separation. That's short. We also talk about triangles, right? The properties of a basic triangle and different type of triangles, and then some of the angles of the triangle, and then triangle types with respect to sides, and then triangle classification with respect to angles that we have seen as some of the properties, and then we more emphasizing on a right angle triangle because that we needed in our trigonometry. We also talk about the Pythagoras theorem and then squares, computing area of a square, and then how area of a square can be leveraged to prove the Pythagoras theorem, something like an hypotenuse square equal to side square plus side square, isn't? And then we also identified like what is meant by adjacent side, opposite side, hypotenuse side within the rectangle triangle. Hypotenuse means the side which is opposite to your right angle triangle of a given triangle, right? So using Pythagoras theorem, if you know two sides but unknown side can be easily calculated, computed, right? So these concepts are a basic prerequisites for us to kickstart the trigonometry topic. All right. Thank you all who are joined today's class. I hope this class is useful. We will continue our trigonometry learning in following sessions. Stay tuned to next session.